Alright, hello, welcome everyone. We have 6 lightning talks on languages that you won't learn in college. So we'll have TypeScript, Dart, Go, Kotlin, Crystal, and Rust. So first up, we have Evan with TypeScript.
Hi, so today we're going to learn TypeScript. That's a strange little reference if anyone. So what is TypeScript? It's basically JavaScript that scales. It's a strict syntactical superset of JavaScript, so it's very similar in style, and just it's better. It transcompiles into JavaScript, so it's compatible with all it's compatible with JavaScript enabled websites and stuff. And it was created by Anders Helsberg, I think, from Microsoft, and he's Danish. Its first public release was in October 2012 after 2 years of development. So what are the benefits? TypeScript code bases are much easier to scale and maintain than JavaScript code bases. If you've ever worked with JavaScript on a big scale, it's pretty fucking awful. It's hard to manage, and it just doesn't work out well, and it's not nice. Another great benefit is if you know JavaScript, you basically know TypeScript. There's not a whole lot extra in terms of how it works and stuff. And type annotations are a huge selling point of TypeScript. It makes it way nicer, and it deals with a lot of issues that people have with JavaScript. And you've access to ES6 and ES7 features for, and other features that it has over JavaScript are interfaces, generics, and other stuff. So what's the catch? JavaScript. You still have to deal with some of the problems that JavaScript brings. And JavaScript is kind of catching up. It has introduced some things that TypeScript has, but again, I do think TypeScript will always just stay ahead of it. And you have even more dependencies, which again, is a huge issue with JavaScript anyway, so more shit. And it's not super useful for small projects. If you're just making a tiny little project, I wouldn't really use TypeScript. It's a lot more hassle than it's worth, I think. And some frameworks don't support it, but they're trying to enable it, and it's because TypeScript is getting more popular, they are adding it. So we'll get into the code of it and give a brief overview of how it looks. So to install it, it's npm install, very easy. So the variables, there is var, but it's I wouldn't recommend using var anymore. It has odd scoping rules. Unlike in most languages, we're able to access it outside of its own block. So for an example, this see here, it's just pretty bad in. Yeah. So instead we'd use let and const. So let it really just works more like how variables should work in most languages, and const works similar to let, but the value can't be changed as the name implies. So yeah, we can change it. So we'll give errors. Object and any, because of the optional strict typing of TypeScript, it's possible to use any and object to avoid using types. However, this is bad practice. It's bad TypeScript practice. We can use methods or as methods function. So yeah, and it has optional default parameters. So here we see if we give in bad parameters, it'll give errors. Using optional parameters, we add a question mark at the end of the name, and that means we don't have to feed in that parameter. And here we have default parameters, so last name equals minute will just be the default. And we have interfaces, which JavaScript doesn't have at all. So just an example is point. We have an x and y axis. The y is optional. And yeah. And Sam over here has contributed to TypeScript. He enabled, or the autocomplete for async, he fixed it. So before we get into questions, I'll just go through the playground. Yeah. So if you go to the TypeScript playground, it'll actually give. Sorry. TypeScript. The playground has just some small, like, just I guess, introduction to the language. So on the left we have the TypeScript, and on the right we have what it transpiles into. So this just shows a JavaScript function. It hasn't really used TypeScript stuff in it. So we run that, say hello, it greets. If we go to the adding types, so here we see that greeting string is the type. That means the greeting has to be the type string, just that greeting equals greeting. It does the same thing, just with types. Here we go. We also have classes, so we have the class greeter, like greeter, yeah. You kind of get the picture. Woo. Just shows just inheritance, then the animal class, kind of the classic example for inheritance. No, it's not anything. Yeah, and then at the end it shows ray tracing example, if anyone's into that. It's long. I'm not getting into that one. So yeah, that was a bit quick, I guess. I guess that's the point of the lightning talk. Does anyone have any questions?
Who uses it?
We use it. CIX. There we go.
It's true.
Me and Noah worked on the front end for our project somewhere. Oh, okay, Kieran.
That's fine.
Yeah, Noah suggested using TypeScript, and it was a good suggestion. Yeah. I don't know if anyone else. Do you? Fidelity.
Thank you.
So, Rust time.
Very nice. Oh.
Okay, so I'm here to talk about Rust. Rust is a, I can't remember what order my slides are in, but yeah, okay. Rust is it's a fairly new language. It came out, I think they started making it in 2010. It's designed for systems programming, which is more low-level stuff. It's designed by Mozilla, who make Firefox. They kind of originally made it to replace bits of Firefox, because they were kind of sick of C. C is very low level, and it's very easy to get wrong. It's not great for that. That shouldn't be there. Okay, something's gone wrong here. Okay, Rust is. I should put this later. Rust is. It's really easy to install. It's got its own like version manager, because you tend to install loads of different versions of Rust because it's very often updated. So you got this. If you just run this, it'll install Rust for you. You've got it. There's also an installer on Windows, and if you're conservative, you can install your distros packages. That's kind of. What's it good for? Rust, it's designed kind of as a replacement for C, but designed to be more expressive. I taught this talk with after Go, so okay. We'll get to why Go is. It's sort of become a competitor for Go, which is a talk that's coming up later. But its main selling point is that it's memory safe, which means you can't leak memory, you're not going to be wasting memory at all. It's type safe, which sort of means you won't use types as the wrong types. It compiles directly to machine code, which means it's really fast, it's as fast as C. Python would be memory safe, but wouldn't compile directly. Go is memory and type safe and compiles, but has a garbage collector, which means it's slow-ish. And those are generics. Generics are, yeah, I don't know. They're fun.
Oh, yeah.
Memory safety, yeah, Rust. This is kind of the main feature of Rust. It uses this borrowing thing, which I can't explain tonight. It's really complicated. It's the main problem people have in Rust, but basically it's a way that ensures that memory is never forgotten about, it's never wasted. Usually languages use a garbage collector for this. Rust just makes sure that the programmer doesn't leak memory. It's not very nice to you like that. Some more of that. Also has a fairly strong type system. I think I mentioned that. So it has inheritance, it has standard stuff like that. It doesn't have inheritance, it has traits. It's kind of like C++ done better. It's got a cute mascot, unlike other languages. I'm just going to throw some code up now. This is Rust. This is how you do Hello World in Rust. If you've done JavaScript, it probably looks similar. It's got the same braces and thing, but instead of function, it's fn. It's more based on C, but JavaScript's also based on C, so that's why it looks very similar. And yeah, that's just a function. It's a macro that prints out whatever you put in it. The next question is, there's loops. Again, very much like JavaScript, but you can do stuff like this for I and whatever. Another thing is, one of the main reasons you want memory safety and stuff like that is if you have a multi-threaded application, which is an application which has, multiple. That's not the example I'm looking for. Did I have it? I don't have it. Okay, never mind. If you have an application with multiple things using, okay, let's start again. If you have an application and you want to run it with multiple cores in your CPU, that's good. It works. But if you're trying to use the same data on both cores, it can break. Because it's two people are trying to touch the same thing and it breaks. Go has this issue, I call it race conditions. Rust, it's impossible to do it because it's enforced compile time. If two things try to touch the same bit of memory at the same time, you'll get compile error and it won't happen. This is kind of like that. It's kind of a contrived example. Like this function, so this creates a vector, which is a list with a single element in it. This function adds to it, but it takes ownership, which means that this can't. It's kind of like saying this owns it, and it can do whatever it wants with it, and it can do whatever it wants after this function goes away. So if this function wants to do something, it can't, because it doesn't know what state it's in after this. So it's kind of weird information. But the other really nice thing about Rust is that it has this really nice library system. It has packages. Yeah, it should have gone up. Okay, weird. It's got libraries. It's done really well, and it's really well integrated with the language. So in some languages like C or JavaScript, you kind of have to hunt around. NPM is alright, but it's the plain setup. In Rust, it's built in. You use this cargo tool. You say cargo add your package. In this case, it's a HTTP library, which will just, fetch some stuff. And then you can just use it. And here's some more Rust code. It's a bit weird, but it's going to all of the URLs. It's going to spawn a thread. Here's just a thread. I was having fun. And it'll just get. So this mightn't look that cool, but for a low-level language that was kind of trying to be like C, this is really nice, because C doesn't do this. With C, this would be like at least 50 lines of code, and this does it, and it does it as fast as C, and as efficiently as C, and it doesn't have garbage collector. So yeah, it's nice. It's got some output, yeah. And yeah, it has a huge amount of crates. Like, they're called crates, packages, they're libraries. You do literally anything you want in them. People are trying to make games in it. I think Chucklefish, who made Starbound and something else, they're using Rust for the next game. I should mention them on the next slide. Who uses it? Chucklefish. Firefox is also slowly converting bits of its code to Rust because it's more secure than C, it's faster than C. Dropbox uses Rust on some kind of file storage stuff. Google are using it for secret projects, which aren't that secret. Yeah, and if you want to read more about Rust, one of the great things is there's so much documentation, people have written so much about it. The best way to get into it would be the book. It's kind of a book. It's just an introduction to Rust, and it's really good. It's recently been updated for new features. Also Rust by example, which is a set of example sets of code which will do stuff. And the playground, which is effectively what Evan showed you a second ago. That's the same thing Evan did. It's just this. You can throw in some Rust code. You don't have to install it. You just do it online, throw in some code, and it'll run it. Yeah, I don't know what this code does because I just copied it, but yeah, it'll just loop through that. So here's a vector, and it's looping through the vector. A vector is a list. So for a name in the names, this is a match. It's kind of like an if statement. So it's saying if it's Ferris, which is this guy, it'll print something out. Otherwise, it'll just print out the name. Yeah, I think otherwise that's it. There's a lot of complicated stuff in Rust, which I can't really explain in 10 minutes. So if you want to read more, it's all there. It's a really steep learning curve. It's really satisfying. Yeah. Any questions? No, that's fair.
You recommend it out of 10?
I recommend it as a fun language. I wouldn't recommend it in production yet. Because other people won't like you if you make them use it. Yeah. But no, it's good. It's a really nice language. It works well with other people. Like, I don't know. I don't know who's next, so very easy. It's you. It's cool.
Okay, so I'm going to talk on Go, and Go is a free open source programming language developed by Google. It was kind of made to solve the large scale problems that Google have as a cube mascot, which you can see here. So the features, it's statically typed, which means type checking is done at compile time. It is compiled. It has fast garbage collection. It's object-oriented, but it has no inheritance. It can be easily scaled because of its nice Go routine. And then simple concurrency, which is done with Go routines. So Go routines it's basically multi-threading, but just a lot more efficient. It costs a lot less to create a Go routine than a thread, and you can use channels to communicate between them. So they're very efficient for scaling programs. And it's as simple as putting Go before calling the function, and it'll be created in a new Go routine. So Go is usually used for the back end of a website and large applications that will require a lot of concurrency. So a server that might have a lot of users connecting, Go would be a good use of that, and REST APIs typically can use Go. And then projects that are built on Go, there's Docker, which is a containerization system. I don't know how to pronounce that.
Kubernetes?
That, which is similar enough, and that's the Docker logo there with the Go logo. Grafana, which is also built on Go, and it is like a dashboard for graphs and stuff. And those InfluxDB and Prometheus also written in Go. Go is the 7th fastest growing language on GitHub, according to GitHub this year. There's 22,000 active repositories currently on Go. And that's the mascot in a sailor hat. So, sample code. What? Yeah. So this is a struct, which is basically an object, and it's called struct in Go. So this is a person, and then it has a main function, like a lot of other languages. In Go, you use a colon to initiate a variable. So I just call that me. Create a new person with the name Oshin. an age 18, and then just print it out. And then to just change the value in a variable is just a normal equals. And if you're interested in learning Go, this is a good link to go to. It walks you through how to learn it. And then we'll go into the playground. So this is the Go playground. I'll just copy and paste this code in. So yes, it just prints Oshin age 18 and then change it to 19 and prints it out again. And that's really it. That was much quicker than I expected. Yeah, any questions?
I'm sorry for riffing on Go.
It's okay.
Go's nice. Go's good. Who uses Go? Like, do big companies use Go?
Well, Google use it because they developed it. I don't know, do any other ones use it?
Work in core.
Teamwork in core. Okay. Who's next?
Okay, hi everyone. I'm going to be talking about Kotlin, which is free, modern, and statically typed language on the JVM or JavaScript or even LLVM, made by the cool guys who made IntelliJ and Android Studio.
No.
Google made Android Studio. PyCharm, yeah, kind of, yeah, it is Japanese, but yeah, whatever. They made all those cool IDEs that a lot of people use. It's going to be your new best friend for Android and anywhere that you use Java. If you use this, you won't want to use Java anymore, because Java objectively sucks compared to it. That's me. I just have to do that. So, what makes it cool? If you've ever done Java, you've surely come across null pointer exception. Well, no more. Type inference. No more having to define types. Almost. Coroutines. Asynchronous stuff. Yeah. Data classes. Probably one of the biggest reasons you will love Kotlin compared to Java. Is anyone ever sick of writing toString and all that shit? Yeah, it just takes care of it for you, the way it should have been. Operator overloading is pretty cool. It's just easy to abuse, but it's cool. Proper function types. I've been trying to do this stuff in Java recently for an assignment. It was fucking terrible, and I admit it. It does it right. Range expressions, they're just nice. So let's go through them one by one. Null type safety. Okay, so here we're specifying a variable called something. Here's this type. We assign it that. That's all cool. Here we assign another string. We assign it to null. That does not work. Why? Because this is not marked as nullable. This is how you make a nullable string. So this is okay. How does it work when you're actually trying to do stuff that could cause a null pointer exception? This is not nullable, so you can just call it like normal. All cool. This is nullable. You can't do this because you have to be like, oh, what if this is null? So you would put a question mark there, and then it's okay. But otherwise, it causes null pointer exception in Java. Alternatively, if you just don't care, just put two exclamation marks there. That is also okay, but if it's null, it will crash. Type inference. It's just nicer. There's no point in just doing that. Coroutines. Okay, so yay, swimming in a thread pool, because coroutines use thread pools. So basically, you do this. This is a function technically underneath. I won't get into details, but basically this is running this, everything that's in here, in a thread separately. So this will run in the background while you can do whatever the fuck you want in between there. Job.join, this is just wait for it to finish before you can move on. Note that from a launch, you cannot return a value. It returns a unit, which is basically nothing.
If you want to return something, you use async. In this case, we're declaring it as returning an integer. This is called deferred. This would be of type job. So, long-running operation, blah, 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 return 5. In the meantime, you can do whatever else you want to do here, and then when you need that value, you do the deferred variable dot await, and then if it's not already finished, it will wait, and then finally give you your value right there, which in this case was 5.
Also a pain in Java. Do coroutines exist in Java? I don't think so. Yeah.
Data classes. Fucking love them. Absolutely beautiful. Right, so data class, make it fruit. 2 properties, weight and name. So then we just specify our fruit right here. 500 weight, it's a banana. And when you print it, as we're doing here, just it generates a lot of really neat functions like toString, like in that example, equals, and then all the different getters and setters based on whether it's val or var, blah, blah, blah. Because who has time for writing that stuff yourself? Just get the compiler to do it for you. Operator overloading. I should have actually put an example for that. So basically, if this was something like Java, you would have to make a method called add, or whatever the hell you want, and then you do matrix.add, and then another matrix. For this example, you can just do matrix plus matrix, because you're overriding the operator plus. It's just a really nice looking thing. A lot of languages can abuse it. You can abuse it here as well, but it's just nice to have as well. Proper function types. Next, I'm going to highlight that proper word, but it really is proper. Here it is right there. That's the variable or parameter name. There's the parameters. You can take as many parameters as you want. Java. There's 1 parameter or 2 parameters. There's a return type anyways. So basically what we're doing is going through everything in this list here and calling that function on each element of this list. So here's a list. That's a cool thing you don't have in Java. This just returns a list right off. Here is a lambda. So here's a parameter, and here's the function you're calling inside your function. So basically, this is the function here. This gets called here, and that's the parameter you call it here. Yeah. It's just done right, or done at all in the first place. Kotlin is great. Range expressions. This is also just a nice thing. Instead of having to do this, just do this. Or I in 0 to 10. The other way around, 10 to 0. 0, 2, 4, 6, 8, 10. And this is 0 to 9, because exclusive. They're just nice things to have overall. Other nice things that it has, it's got a lot of stuff. It's a pretty big language. First class delegation. Has anyone ever done delegation in Java? Yeah, we have. Computer science will be doing it in second year with Don. God bless. First class delegation is literally just 2 extra letters and you're delegating. Java interoperability. So there's a lot of nice Java libraries and all that stuff out there. It'd be a shame if they didn't work. Kotlin got you sorted there. You can use any Java library in Kotlin and vice versa, and it just works. String templates. No more pluses and stuff. It's just straight in a string. Smart casts. They're smart. So basically, let me just give you a quick rundown on that. So if you've got a null type, and then you check, is it null? And if it isn't null, in that if statement where you check if it's null, it'll be like, oh yeah, I just checked that it's not null, so it's not null. And then it works as a non-nullable type. It's pretty smart. Extension functions, adding methods to already existing classes. Inline functions, that's just a small performance thing. Not really a big, well, it is kind of a big deal for some people, but yeah, don't worry about it. companion objects. It's a lot like static, but with more. Kind of. Maybe not. It has companion objects. Who uses Kotlin? Uber uses it. HubSpot, Google, Airbnb, Pinterest, Trello, blah, blah, blah. A lot of people are using it for Android, especially these days. That's why there's this pretty sick image right there. Android. Android, oh yeah. Android. Let's get Kotlin one next time. That one reminds me of Java, because it's bloated. Alright, some fun facts just to wrap things up slowly. It rose from the 65th most popular to the 27th most popular language in just 1 year. I mean, it must be pretty cool then. 80% of Kotlin developers use it for Android, because after all, when was it? 2017? 16? 17? One of the two. 17. Yes, it is 17. Yeah, it's in the next point right there. Yeah, 2017. Google announced that it will have first-class support in Android. Hence, everyone, well, not everyone, but a lot of people use it now. Students love it as well. I hope you do too. And it's officially supported by Gradle. So, yeah, goodbye Groovy. I don't like Groovy. It's dynamically typed. Not good. What's next? And yeah, there's a playground like all other good languages. Does that take me there? Well, I already have it there. So yeah, you just hit the play button. Hooray! Yeah. You can try it out there if you want. This goes down. What do I have here? Oh yeah, it's just an example. So here's just the main function, like all other languages. So you're in Java and you want to run something. You have class main or whatever, and then you have this big fuck off piece of line called public static void main. And you're just like, this was a mistake. None of that shit in Kotlin. You just got that straight thing. Oh, I should have put a string there. That's besides the point. New in 1.3, you don't even need this. Just fun main. Fun. Yeah, it's fun. It is fun. And yeah, so here's a list of numbers. See, you just have this list of things. You also have array list of, and you also have hash map and blah, blah, blah. You've got a load of neat helper functions because productivity is key. Simple for loop. None more of that system.out.println line. I mean, Jesus Christ, could they make it any more awkward? Abstract class. Here's the parameters right there. It's just one line. I mean, you can't really beat that. Here's an interface. That's the same. And then here you have a class. It's called banana. It takes one parameter here. And so, you know, in Java you would have your constructor, and in there you would call super and pass in parameters. That's it right there. Personally, I love this. This looks pretty nice. So this means that banana extends fruit, and we're passing in the parameters to the superclass as it defines here. And here we are implementing the interface munchable. Here's override, no longer an annotation, it's now an actual keyword. Another fun thing right there. And oh, there's string templates right there. You see we're referencing the variables here and here. Pretty sure this is runnable for the most part. I just have to put in a thing. Anna 500 dot eat amount 50f. Oh yeah, because this was a wrong thing. Hey, who said that? Hi, how are you? Don't worry, fellas. This was all planned. I've been using Java a lot.
No, it's going to list on array.
Yeah, you're doing this into an array.
Oh yeah, of course. We've got array of. Hey! I've been doing Java too much, it's getting to my head. And then here's just some nice pictures behind this. See, Google's having an affair with Kotlin. She's pretty heated. Yeah, I'm getting out soon. Don't worry. Hey, more puns about Java being slow. Or bloated even. So yeah, if there's any input, I'll divide it up between each person, else I'll fuck off. So, any questions? Yes.
Why would you ever use Kotlin 2.js?
Got me stumped there.
Playground.
Hmm?
Just playground.
Playground? Good question, it might. Personally, yeah, I don't know. Just use TypeScript, honestly. Any more questions? Yes.
You mentioned val and var.
Ah, yes.
What are the differences?
Var is like var or let in JavaScript. Val is like const. Any more questions? Fulham's raring for a question. There you are. Okay. All right. That's that then. Yeah.
Done. And then? Yeah. How do you do that?
Oh, it's nice to know this.
I'm a student there. No, just sit here.
Cool. So I'm going to do a language I don't actually know. So I'm off to a pretty good start there. So it's called Dart. Unfortunately, it doesn't have any nice mascots or anything like that. The logo is kind of boring, to be honest. So what is Dart? Dart is a multi-purpose language. So it can be deployed if you want to write mobile apps, if you want to write web apps, or you can use it on the server side. It has optional static typing, which I guess is better than having no static typing whatsoever. And it's developed by Google. Google like developing languages for some reason. So Dart started off as an experiment to replace JavaScript in the browser. It's very ambitious, but like it's never going to happen. Like as horrible as JavaScript is, it's kind of here to stay. It was implemented as a thing called Dartium, which took Chrome and like embedded the Dart VM in it. Unfortunately, I think that's been discontinued. Yeah, as my slide does say. So yeah, it's been replaced by a transpiler. So if you write Dart code, what will happen is it will just convert it to JavaScript essentially. And that little script tag is something you could have done with Dartium. I liked it, but it's gone. So with Dart, there are 3 compile targets. So you have the browser, where you can transpile from Dart to JS. You have mobile, which is like a separate framework. It's called Flutter, also developed by Google. It targets iOS, Android, and a project like Cole mentioned earlier called Fuchsia. So essentially what you can do is you can make a mobile app that runs on all of those operating systems with one code base, which is very nice. With Flutter, it compiles down into either ARM code or x86 code. So you get like full native performance and stuff. Like it's not. If anybody's used React, it's much better. Like it's much faster than React. You can use it on the server side. So if you're writing networking applications and stuff, it's quite a good choice in terms of speed and stuff. In terms of actual support, probably not. There's not really a large community around the server side end of it, I don't think. And the API is similar to Node.js, which I'll be doing a mentorship on next semester. So yeah, this is just, it's actually incorrect. I'm so like down the Node.js rabbit hole. The second code block should say window.addEventListener, but whatever. So in Dart, you have to declare a main function. So this is the entry point to your script. When it's transpiled into JavaScript, that just becomes a function that's passed into the DOM content loaded event listener. So it runs as soon as the DOM is loaded. So if you want to declare variables, you can use var, which is familiar to anybody who knows JavaScript. And you can also annotate variables with types. You can also create static variables and stuff. I didn't include that there. But. So functions are pretty standard as well. Out of the box, Dart comes with template strings, so you don't have to. You can like embed variables in the strings and stuff. It's quite nice. The second function there, you notice that the third parameter has braces around it. So when you're defining a function and you have braces around a particular parameter, it makes it optional, so you don't have to pass it in, which is, I think, is quite nice. And then you see in the second block there, the last example, if you want to specify an optional parameter, you just do the parameter, then colon, and then whatever the value is. So I guess like this is the most exciting thing about Dart at the moment. Google covered a lot of this in their last Google I/O, I believe. So as I said before, Flutter is a mobile UI framework. It's built in C++, Dart, and I believe Objective-C, I suppose, for the iOS part. So that example there is an app. Yeah, it's pretty simple, and it's based around widgets. Yeah, I mean, I've only played around with Flutter. I haven't really used it too much. I do have a video of something made with Flutter. I think the audio is not on. So it doesn't use the native UI framework. So like if you use this sample app on Android and you switch to iOS, it'll just look like iOS. They've recreated everything, which I think is pretty cool. But also, why would you want to do that to yourself? And yeah, it's pretty nice. And that's it. Any questions? I probably can't answer them, but nope.
Are any like apps we know of using Flutter?
I don't think so. I think some, you probably know more than I would, but I think some Google internal apps use Flutter. Something for the advertising platform there.
I know that the first app made with Flutter was an app for Hamilton the musical.
Oh, there you go.
Yeah, there you go. Don't ask me how I know that.
Cool. Any other questions?
Is there like package support for like do a lot of packages for JavaScript support in Dart?
I don't think you can use JavaScript packages with Dart. Or maybe you can. See, I don't know. I imagine you can, yeah, if you're transpiling it. Dart itself has a package manager, which I can't remember the name of. I think it's Pub or something. It's not that big, but it has a package manager. Any other questions?
Having researched it, are you going to learn it at any point? Are you interested in it?
I suppose, yeah, at some point. Maybe not now. Cool. Any other questions before I go? Nice. Thanks.
All right. So instead of doing one language I don't know, I'm actually going to go do two languages I do because they're very similar. I'm going to do Ruby and Crystal really quick, mainly because Crystal looks a lot like Ruby and it's just better in many ways. You know Noah's slide on why Kotlin is great and all these ideas? I was reading through it and I was like, yeah, Crystal has all of them. She'd probably like Crystal too. I followed a lot of my style from the CSS talks. So yeah, we're just gonna, you've seen all that. This is from Ruby's website. It's a dynamic open source programming language. The word dynamic should scare you if this set of talks is anything to go by. Yada yada. It looks really nice and it's easy to read and write. Yeah, well, I'll show you that now. Functions. So a lot of people don't like end, and I get that. But yeah, it's pretty basic. You know, if you've done Python, you probably it should look kind of familiar. It's just instead of indentation, you use the word end. It's sometimes easy to forget when you're doing a lot of other languages like I do, and most of my issues are the fact that I forgot the word end. It's got string templates, which is a thing I saw pop up a lot. Yeah, got a hash and some curly brackets. You can do some string templating. You do loops. Ruby has for, like the FOR, but it's actually, you're not meant to use for because that's just not the way Ruby does things. Ruby's too cool for for. So you have 3.times, which 3 times. Or you can do .each for an array. There's other stuff. I've kind of spoiled it. Do I close the door? I'm trying to talk and let people learn. I kind of spoiled a little thing, and I'll show you that later. But yeah, you've got .each. You can do .each .with index to get your number and your index, and if you're doing for loops with parameters, pop it inside there. There's another way of doing it, but I'm doing 2 languages, so I'm not going to go do super detailed stuff. Classes. This is another syntax thing that does bother people. Instance variables, class variables, 2 ats. You've got initialize, that's your constructor. One really cool thing is Noah touched on earlier, class extension. So this is the built-in string class. And I can open it up and add a hello method, which prints out hello world. And then I can call that any string, and it does the thing. That's really cool. I think Kotlin has it. I think a couple other languages might have it as well. JavaScript? JavaScript has it?
You can change anything. Though.
Oh, well, yeah, okay, the prototyping thing. One nice little convention is interrobang, but it's actually question mark and exclamation mark. There's exclamation mark methods, which, so you see l.sort returns a sorted list, but it doesn't change the actual list. But if you do l.sort, it sorts the one in memory. Sorry, because not my own jokes. And also, empty. Well, you're basically asking a list, is it empty? Question mark methods. So I'll actually say with exclamation mark methods. They affect the stuff in memory instead of returning a new version in place. I think is the word. And question mark return a boolean. So you're basically asking the thing, hey L, are you empty? Yeah. Sugar. It's got a lot of syntactic sugar. I gave one example. Unless. Yeah. So instead of doing if x is not 1, you can check. Or you can say if it's not equal to 1, do this. You can say unless it's 1, do this. I mean, it's basically the same thing, but it's cool. Because you can do stuff like return true unless x is 1. But you can also do if x is not equal. It doesn't matter, right? You'll see in a second that Ruby has a lot of ways to do things. One I don't like, returns are completely optional. It'll return the last thing it gets to in a function. Don't like that one. Rust does that as well, I've just been told.
So does Kotlin.
So does Kotlin. Jesus Christ. I like to leave my return statements in just so that when I'm reading it back 5 months later, I'm like, what the fuck does this return? And lastly, parentheses are optional, which is something I spoiled earlier with my for loops. But without parentheses, these ones are optional as well in Ruby, but they're not optional in Crystal, and that's why I left them in there, because Crystal is the right way to do it. But yeah, you don't have to specify function calls with brackets, unless you're in some cases when it's like, if I had another parameter to go to puts and you put it there, it's like, is that for this function or that function? I don't know. Yeah, it doesn't matter. Yeah, so that's Ruby. How to install it? If you want to put Gentoo up there for you if you want.
Thank you.
Yeah, it's on every package manager. Even if you use Pacman, it's there. You don't need to do the AUR stuff or use the Playground. Ruby has a Try Ruby, which is kind of like a 20-minute introduction to the language. I'm not going to go into it because the Crystal one is way better. If you haven't guessed by now, I like Crystal. So pros and cons. Nice syntax. You don't need to have all the punctuation. You can extend classes, which is pretty cool. everything's an object, so you could do 3 dot times. Cons, sometimes there are too many ways to do things, like if not or unless. And it's relatively slow. It's slower than Python, which brings me to the next point. Boom, Crystal. Fastest C, slick as Ruby is their tagline. But so basically, it's Ruby on steroids. It's way faster. It was faster than Go for a while as well, actually, even with garbage collection. So it looks like Ruby, so I'm not going to go too into the syntax, but type definitions. Get 2 returns an 32-bit integer, return number 2. See, I like when it returns because this gets confusing. Nullable types also has null safety. So if you try to do stuff with this, it will say, hang on, this could be null. Hold on, are you sure you want to try this? Another thing, which I threw in because it's really cool, is macros. So this is essentially a function that makes a function. So you say, it takes a name and a message, and it makes a function with the name and puts that whatever you put in. And I'm saying make a method called Netsoc that prints out this message, and that's what it puts. That's what it defines at compile time, and then you can run that function. And Crystal is cool. Yeah. How to install? It's not as commonly on package managers. You have to do it through a script that they give you for Ubuntu and CentOS, the non-important ones. It is on Pacman, and Shards is its package manager. It's pretty cool. Playground. The nice thing about the Crystal Playground is I can actually, I already had it open. All the code I put in my slides is up here, and if you want, you can go in and you can fuck around with it. You can edit it, and then you can compile and run it, and it does all the cool stuff. And it's all here. See, look, macro. Crystal's cool. It is. Pros and cons. It's got all the Ruby pros because it's better than Ruby. So you've got stuff like extending classes, you've got the nice easy syntax, you've got whatever the hell the third thing I put there was, doesn't matter. Static typing and compile time type checking. That's a phrase you've probably heard a lot now today. You might be sick of it like I am. It is faster than Ruby, and it's also faster than a lot of languages. There's a little article just to beware if you're comparing it. This is just to Ruby. It kind of goes into detail about how you can't just say, oh look, Ruby did it in 37 seconds and Crystal did it in less than a millisecond or whatever, but it goes into detail about the difference in why the difference in time is so big, and it's really cool read. I recommend it. Yeah, but Crystal's fast AF. The only thing about it is it's not fully released yet, so there's a lot of breaking changes. I'm constantly having to fix my own project because they keep breaking stuff. Multiprocessing isn't fully working yet, but there are what are called fibers, which are based off Go routines. They work pretty much the same way. And no Windows support, but who the hell cares? So. Yeah, I see that Noah stole my style of asking questions.
Didn't even remember you had that in.
Sure you did. Have you got any questions for me? Yes.
So what are the benefits of using a language that isn't fully released yet?
Well, first of all, I can say I'm a hipster. Second of all, it's kind of fun to just watch the ecosystem evolve because it does have quite a large ecosystem. And I'm this close to actually helping contribute to the language, but I don't know, something's holding me off. It's just a really cool language, and it's what?
You're scared.
I am scared. I'm legitimately scared. The nice thing about the reason I use it is because I want speed, and I don't want to deal with C or C++. Because well, actually, Rust is fine, Go is fine, but this was the first one I did, and this one has stuck with me because Crystal is it's got the nice syntax. So yeah, take back Go and Rust.
You use these languages.
Ruby. Okay, so there's if you hear about Ruby nowadays because it's slow and stuff, you'll mainly hear about it in the context of a thing called Rails, which is Ruby's Django or Ruby's whatever. It's a web framework. And I guarantee most of you have used it at least once because GitHub is written in Rails. GitLab is written on Rails. That's cool, written on Rails, yeah. So yeah, GitHub, GitLab use Ruby. In terms of Crystal, I don't know because it's not production ready. Well, it's not full version. It is production ready. I'm pretty sure there are people who use it in production. The Crystal website even says there's people using it in production, but I don't know who they are. Yeah,
So you know the question mark in function instead of returns a bool, is that just a convention?
it's a convention, yeah. It's not like it doesn't check, hey, this returns a bool, fucking put a question mark at the end of it. It doesn't do that. It's just a really nice little syntax convention, because then you're just like, oh, that must return a bool. Anything else? And I did away with my style because I wanted to show off my cool gradient. Yeah. Thanks.
Okay. Thanks everyone for coming out. That was it for talks. Thanks to Evan. Yeah. Thanks to Evan, Colum, Fionn, Noah, Basheen and Kieran for your talks. Very, very lively talks. All the slides will be put up online, and I believe a video will be going up as well. Next week we have a talk from our friends at KIGS, a talk by Jury on cybersecurity and
Something
data
to do with
center. It's not confirmed. And our gaming event next week is Pokemon. So yeah, Pokemon week. So yeah, I'm interested.
So inheritance. Yes.